This is Cindy Kelly, and I'm in Boulder, Colorado. It's June 25th, 2013, and I'm going to be interviewing Bert Mills Tolbert. And its first question for Bert is to say his name and then spell it.
My name is Bert Mills Tolbert, spelled T-O-L-B-E-R-T.
Great. Why don't you start with the very beginning and tell us when you were born and where, and then a little bit to lead up to the your education in the Manhattan Project.
Right. I was born in Twin Falls, Idaho, in January 15th, 1921. This is a small town in the southern part of Idaho in a farming community. I graduated from high school there and spent my first 2 years of college at the Idaho State University in Pocatello, Idaho. From there, I went down to Berkeley to the chemistry department of the College of Chemistry at the University of California in Berkeley and did my undergraduate work, and then from there I went on in the graduate school of the Department of Chemistry of the University of California, Berkeley.
So what year would that have been that you started?
Okay, I graduated from high school in 1938. I finished my 2 years in Pocatello in 1940. In 1942, I completed my bachelor's degree in Berkeley. And then in my graduate work, I finished and received my PhD in 1944.
That was fast.
Yes, but those were war years, and we were being pushed at a more rapid rate than was normal. You would have expected 5 years, but they were in a hurry, and things were going forward fast.
What was it like to be at Berkeley?
It was a wonderful experience. Idaho is relatively provincial, even though my mother was very well educated. Master's degree when women didn't go to college from the University of Chicago. My father was also from Iowa, and they steered me into the University of California at Berkeley as a good place to go. And at that time, remember, chemistry was one of the golden children of the development period. Everything was chemistry and more chemistry. Now today, things are obviously computers and electronics and so forth. But that was a great period of evolution. And so that was why I went into that particular field. And also I found it easy and enjoyable.
Just thinking about the Berkeley campus, where was the chemical engineering department vis-a-vis the physics?
Okay, it was just uphill from them. The college, Berkeley is unusual in that it has a college of chemistry, and so they have a dean of chemistry and engineering. And so there was a department of chemical engineering in the college and a department of chemistry, which is now a department of chemistry and biochemistry because they have changed. Their buildings were directly above the physics building on the campus, and there was a lot of interchange between the chemists in the department and the physics department there. The chemistry department is right adjacent to what's called the old radiation laboratory, where E.O. Lawrence built his initial cyclotron, and then up on top of the hill, called On the Hill, was the radiation laboratory where he built his large cyclotron and did the experiments on it. It is interesting that that cyclotron was the magnet that was used as the testing and model devices for the calutrons which were built in Oak Ridge. And so therefore, the radiation laboratory during the war years was really the research site and the test site for the calutrons that were being made and used in Oak Ridge.
So when you were there, was E.O. Lawrence someone you had heard of? Was he
Oh, very much so. I saw him rather regularly. I would attend seminars in physics department, and there was, and remember that the people there in the cyclotron were trying to isolate and work, and they needed chemists. So chemists were widely used in and cooperating with the physicists. I didn't know E.O. Lawrence personally, but I certainly knew him by sight, and I had probably been introduced to him somewhere along the way. Now, you will find, and later on in the story, that I developed some facilities in the Donner Laboratory of Medical Physics. And the Donner Laboratory of Medical Physics was headed up by John Lawrence, Dr. John Lawrence, who was an MD. and they both cooperated, and certainly E.O. Lawrence cooperated in helping John Lawrence in the use of radioactivity and radioisotopes in the medical experiments. This was an attempt to use radioactivity and to use modern physics in the medical world. One of the first type of this, very much ahead of its time, since that building was built in, I think, in 1940. Well, my story was that I was a graduate student in Berkeley and was getting deferred because this was a time when everybody was being subject to the draft. Because I was a scientist and they wanted to get us trained rather than drafted into the war, they deferred us. And so for the first, I started my graduate work in the fall of 1942. And I was teaching classes teaching the laboratory class in chemistry and doing work on my graduate work. In 42 and in the summer of, and then in the fall of 43, I was teaching again, this time in freshman chemistry, because they wanted every graduate student to have an experience in teaching general chemistry. At the end of 1943, I was called into the chairman's office in the chemistry. He was Wendell Latimer, who is probably well known in the records of the atomic energy work at that time, and by his secretary, whose name is Mabel, and said, "You're not going to be a teaching assistant next semester. You're going to go to work for the radiation laboratory," which is what it was called, on the Hill. It was fine. I had my choice basically of doing this secret work, which I was very anxious in doing, or being drafted, because that was the end of my draft deferments. All right. So at that time then, I had to get a clearance. That actually took almost 2.5 months. It was not an immediate process. In the first place, in Idaho, where I was born, they had neglected to send in any data on my birth, and I had no birth certificate. And so it was necessary for my mother, in the middle of the winter, in the middle of February, to drive to Boise, Idaho, and fill out in her own handwriting a birth certificate for me. This, together with the other documentations in the process of clearance, was given. And then in approximately the middle of April, why I started to work for the laboratory. My work in the laboratory at first was to work alongside of chemists who were already working with uranium. You see, in the calutron, the uranium, which is separated into two streams of beams of metal ions. One of them is the 238, and one of them is the uranium-235, and they are caught in carbon pockets. These pockets are made out of the same thing as anodes in a battery, because they're conducting for electricity, and these beams are really like an electrical stream. After they have been running for some time, then they take these out, they cut them into pieces, and then the uranium has been beaten into the carbon, so these are then put in a furnace, ignited, and the carbon all burnt off, and the material is then sent to the chemists. Okay, get the uranium out of this thing here. We want to see how much enrichment we have. So the laboratory that I first worked in worked just simply on a chemical basis of trying to enrich these individual samples. The samples were then sent to a physics laboratory where the amount of fissionable material, 235, was measured by an activation process with neutrons. By the way, the laboratory was highly segmented. I, as a chemist, had access to the chemistry laboratory. I did not have access to the laboratory where the physicists were trying to measure how much fissionable materials were in the samples. I did not have access to the cyclotron area where the calutron was located, but that was all right. I mean, we were busy. We were trying to do the experiments. The laboratory actually was sort of interesting in a way. There was a lot of young ladies and older ladies there who had had some kind of chemical experience, and they worked there. Because of the fact that there was not a great deal of social life, many of these women in the laboratory actually had husbands who were somewhere at the war. They were really very sociable units, and we had picnics on weekends and a very nice time, and I got acquainted with a large group of friends. It's amazing how under these conditions you make good friends and have a very pleasant time. Well, anyway, after about 2 or 3 or 4 months there, they hired some more people, senior people in this case, and the object of it was to create a laboratory that would try to find better ways of purifying the uranium in these ashes of the pocket. Now, you might think that this carbon was just nothing except carbon, and you could burn it off and you would just have that. But unfortunately, these charcoal anodes contain practically everything in the world that coal contains, because obviously they were made from coal. And so that they contain an impressive range of all different kinds of impurities, which made it relatively difficult to get the uranium out. And so they decided to establish another laboratory. The buildings on top of the hill where the cyclotron and where this chemistry laboratory and the physics laboratory was located was much too small, and there wasn't developed area on top of the hill. I don't know whether you know what the Berkeley site was like at all, or you know the Berkeley campus, but the Berkeley campus is down below, and there's a steep hill, and then up on the top of the hill there is a flattened area, and that is where Lawrence had built his cyclotron. He wanted to get it away from any of the buildings on that, and so that was called the radiation laboratory. Okay, however, John Lawrence's, Dr. John Lawrence, who was E.O. Lawrence's brother, was an MD, and he had started a building in approximately it must have been approximately 1940-41, to try to use radioactive isotopes and radioactivity and modern physics in the progress of medical problems. This is one of the early examples of the attempts by medicine and other parts of biology to integrate with the other sciences and find out ways of using them. Okay, so he had built a lovely building with 3 floors, and he didn't have enough money to finish the top floor at all. Apparently, the management, E.O. Lawrence, rented whatever kind of arrangements. I had no part of those arrangements, that the whole of the top floor would be assigned to this unit that was going to do then detailed studies on how better to purify more simply and more easily the uranium from these pockets from the calutron. And so that was set up. For some reason or other, I don't know why, I was given the assignment of designing the laboratories for these the buildings. Part of it was that I had, having been raised on a farm, a knack for working with all kinds of machinery and instruments, and that had come out because I taught the laboratory in organic chemistry. And so I was the one who made the specs, of course subject to approval of the other people, for a laboratory which would hold approximately 8 research people and with 2 large hoods. And it was in this unit then that a number of us were working together to develop better methods of purifying uranium, okay? One of the methods that I got involved with was what's called a countercurrent flow separation, the standard type of thing. And so we devised a way that was very efficient for removing uranium from the sampled materials. It was so good that we could even get the uranium out of ocean water, which has a very small amount of uranium in it. And we made a model of this material, of this machine, and it worked well. And so then we were authorized to make a model for shipment to Oak Ridge where it would be tested. So I was sent together with an engineer to the Oak Ridge National Laboratories. What time would that have been? Probably at the very end of 44 or the beginning of 45. Probably in the beginning of 45, to see about the sites that they had for this operation. And that would be in Y12, of course, where the calutrons were in operation. This was a very interesting experience for me. Now remember, I am a farm boy, basically, from Idaho, although I had traveled back to Iowa and things like that. I had never been exposed to any southern states. And so here I was, loaded onto the train in Berkeley, and we went to Chicago. Now, I'm sure you must have had tales about the Chicago stopover site. But in Chicago, there was a hotel which was located rather close to the Museum of Science and Technology. I don't know whether you have ever visited it, but it's a lovely museum. I was happy to have a stopover there because I think I had at least a half a day to go over and wander through this museum at that time. And then at this stopover place, by the way, we were treated royally. The train that we were on, I had a private compartment. The meals were absolutely gorgeous, and everything, of course, was being paid for. In Chicago, we were then taken to our next, which was I don't know what railroad it is, but it went down to Knoxville from Chicago. And it was a most lovely train, old-fashioned, comfortable to the extreme. The service was immaculate, and it didn't go too fast so that you could enjoy the scene around. And so down to Knoxville I went. My first experience into the South. At Knoxville, then we were picked up. At every place that we went, we were taken care of immediately. There were people waiting for us and to make sure that we went on our way, and then went out to Oak Ridge, taken out to Oak Ridge. I'm trying to remember where I stayed, but there were several dormitories, not dormitories, but we had rooms in them. And there was a main one, which I stayed at, as you'll hear in a moment, on my second visit to Oak Ridge. But on this first one, it was a relatively ordinary room, very nice. And then I went and we looked at the various sites that they had and proposed for us to use, or I think I didn't have any choice. I only had one site, and we looked at it to see what we would need in the way of utilities, power, electricity, and everything else. I think that first time I spent almost 2 weeks down there. It was a very pleasant 2 weeks. As you know from the people who you've talked to about Oak Ridge, it was muddy when it rained. It was dusty when it was dry. The young ladies who worked in the offices would walk barefoot to where the bus left off and to their offices, put on their shoes, and then look very proper. And it was a very segregated existence. All of the rules of the separation of the blacks and the whites were maintained, but everybody was very nice. They were very nice. The meals were good. It was a pleasant experience. In addition to that, I had weekends to see something of the South. And I remember going over to Gatlinburg and looking at the Smoky Mountain Pass in that area. I remember traveling to to the dam, the TVA dam, which was quite a sight. I think I once went to Knoxville itself, but I didn't find it very interesting. But the whole country was another world for me. There was a stopover place in Santa Fe for the people who were going to Los Alamos. There was a stopover place in this one in Chicago. And
so was it a hotel like in Santa Fe? La Fonda was right there on the plaza. Did people stay there, or do you mean the office that 109 East Palace where Dorothy McKibben would greet people?
After the war, I went down to Los Alamos, and there I flew in with a small plane, and I was directed to go to an address which was in a street off from the plaza, but very close to the plaza. And there I went and checked in, and I waited then in the plaza until they sent a car or something or other to pick me up. I didn't stay overnight for there, although if it was appropriate, I could have. But this was a regular stopover because I used it twice, and I know all of the people from Berkeley used it and stayed there, because usually the train got you in at one time and the train going down there. On the other hand, we also, toward the end, I think the last trip I made at least one of the legs on a plane.
Oh, that's interesting. Was it, just one more question on this, was it a hotel that was totally dedicated to people involved in the Manhattan Project, or was it just a general hotel?
I have no idea.
Okay.
I rather think it was a general hotel, but one that had been briefed on that to take care of us and to make sure that we didn't get into trouble, and got on the train the next day. Do you want? There is very little that I can say about the operation at Y12, because I was not allowed to go visit the calutrons or any other part of the Y12 facility. It was not part of my assignment. I was a chemist and was responsible for purifying the uranium after it came out of the pockets. It was highly compartmentalized. It was compartmentalized in Berkeley. It was compartmentalized there and everywhere else. And that was an important part of the maintaining of the secrecy of it. And furthermore, because we could not visit those, we did not talk about technical matters to anybody except our own work. It is quite interesting that how completely isolated they were able to, at least for the people who weren't intent on something bad, to maintain the secrecy of this. We used a code name called Tubaloi, which has been published and was well known, and our symbol was T, as instead of uranium, or U in our notebooks. And of course we were not allowed to take any of the material, written material, or any of the documents outside of the laboratory. So as a result, there was a very clear demarcation from the eight hours in the laboratory and the rest of your life. I'm not quite sure whether we worked a 10-hour day or a 8-hour day. I think maybe at first we worked a 10-hour day, and then it was shortened down to an 8-hour day later on. But we did work Saturday mornings every day. As far as I was concerned, I was a graduate student and working for my degree and working on my thesis, and so my life basically revolved about the 8-hour day at the laboratory, coming back, getting dinner, and then going back to my other research laboratory in the chemistry building of the Department of Chemistry, and working till approximately 10:30 there at night, going home, to bed, and up, and so forth. And this routine I maintained practically the whole of the 2 years that while the war was in progress. It was not an unpleasant life. The weekends that were available, we had money, but there was nothing to spend it on. People didn't have gasoline, they didn't have tires for their cars, but in the Bay Area there was an excellent streetcar system. There was a train that took you over to San Francisco. You could take the train to San Francisco on Sunday, catch a cable car part way out toward the ocean, catch another streetcar to the big Golden Gate Park, the famous park in San Francisco, and have a very pleasant time. You could also rent a bicycle if you want to and go bicycling over to Marin County, going across one of the bridges. So life for those of us who were working on this was really relatively pleasant, and we had good friends and made good friends in the laboratory. All right, so I came back, and we they finished getting the facilities that we needed in the in the Y12 area, and the instrument was shipped to them, and then I was sent again to there to be present as they were trying to set it up and run it and help them in this operation. So on this second trip, it was basically the same as the other, except for one sort of interesting little incident. That apparently the rooms in the hotel, hotels, were all filled, and so they didn't have any space for several of us. And so the E.O. Lawrence, director of the Berkeley Laboratory, had a special apartment in one of the buildings that were reserved for him. And so they said, all right, you can use that E.O. Lawrence's apartment. This was sort of an honor, of course, and it was quite interesting. The interesting thing about it, though, was that I'm sort of quiet and not very likely to do odd things, but these were a bunch of young engineers, and one of the things that they noted relatively early was that it was so dusty that if you could reach up and touch the ceiling, why, you could leave a mark there. So they, of course, grabbed one of their guys, turned him upside down, and had him walk across the ceiling of E.O. Lawrence's apartment. And then we came down, and I thought, surely somebody's going to get into trouble for this. But I never heard of it. I think that the maids probably saw the footprints in the ceiling and dusted it down. But that sort of represents some of the more relaxed days. But it also shows you what a dusty, dirty place Oak Ridge was at that time before it had been sealed in. Well, it wasn't so long after our countercurrent extraction apparatus for the uranium was put in that I think what happened, but I don't know for sure, is that they had enough uranium enriched for one bomb, and the other facility at Oak Ridge, which was the diffusion process for enriching uranium, was being very successful and much more efficient and producing a lot more material, and so they never used the apparatus that we had constructed and designed. And furthermore, in other laboratories, different technologies for enriching uranium were developed, which were more efficient than the one that we had chosen to develop. So peace was declared with Japan, and we were all sitting around saying, okay, oh my gosh, we got to find jobs. Where are we going to go? I hadn't even made any decisions on it. We were probably still writing up documents, and we were still getting paid, and we hadn't been fired yet. A professor in the chemistry department in Berkeley by the name of Melvin Calvin, he became very famous later on for his work on photosynthesis and the use of and got a Nobel Prize for it. But at that time, he called us, me and two other of the graduate students, to his office and said, I have gotten authority from E.O. Lawrence, from what was essentially the precursor of the AEC. I don't know whether in December it had been actually created. It had been, okay. And from John Lawrence to use the facilities that we had been using for uranium enrichment to set up a group that were going to develop the use of the isotope carbon-14, which had been discovered just at the beginning of the war and had not been developed because it was not part of the war effort. And this group that he wanted to set up was to figure out how to make the material in large quantities, how to assay it, how to make it into compounds that would be useful in medicine, biology, chemistry, whatever, and demonstrate that these experiments would work. And so, of course, we were overjoyed at the opportunity to participate in this experiment. And so so the bioorganic chemistry group was created by Melvin Calvin at that time, and we became the initial members of that group. It is interesting that this was the first group that was set up to exploit the use of that in the laboratory. Within, later on in the next year, which would have been 1946, Oak Ridge National Laboratories, the Brookhaven Laboratories, the Chicago Laboratories, all set up spatial laboratories modeled after ours to use this isotope and develop it in useful peacetime applications. We worked very hard and very fast, and starting then, you see, in 46, by 1948, we had done and achieved enough of our goals that we were able to sit down and write a book called Isotopic Carbon, which was published with a publishing date of 1949, and with Melvin Calvin as the lead author, and 5 of us, including yours truly, as the other authors. That is a very interesting example, though, of how quickly facilities and knowledge and ability that had been gained during this war were turned into something very useful very quickly for medicine and for all of the sciences.
That's excellent.
Eventually, I became assistant director of the laboratory, and stayed there until 1957, when I accepted a position, a professor of chemistry here at the University of Colorado in Boulder. More questions?
Well, it's interesting, you started the theme of the innovations that were developed during the war for war purposes and how they were sort of translated after the war. Can you think of other examples? What about your innovation that you developed? Did that ever turn
Of things that came out from the war?
Yeah, right. or we could pick up on the Lawrence brothers and their treatment of cancer with the radioactive substances.
Yes. Certainly that was one of the very big hopes, and it turned out in many different ways. Our particular thing was not the treatment of the cancer necessarily, although we had considered the possibility of making samples with enough radioactivity in organic materials that they could be administered and would seek out the cancer and irradiate and rent. But carbon-14 has a very low energy radiation, and it just doesn't work very well. Thank goodness, because that makes it a very safe radioactive material to use in studies. So its primary usefulness was in locating where a given compound, for instance, if you give a patient a drug and you'd like to know where does it go, by following where it's excreted in the fecal materials, in the urine, is it in the tissues, how rapidly does it come out. This material has been used for very extensively.
That's exciting. One of the things I've read is that there were a lot of Soviet spies or agents around Berkeley, and they kind of tried to pick off graduate students that they thought might be willing to provide them information. Were you aware of any of that kind of activity?
I was aware, quite aware, that there was, of course, communists and socialists and very other people. And in fact, for what it's interesting, as an undergraduate there, my first 2 years, I lived in something called Barrington Hall on Dwight Way. Barrington Hall was an old apartment house that had become not useful as that, and it was made into a co-op. Now, of course, co-ops are very liberal people, and but I lived in it with my brother, who was also a student in Berkeley, and a number of in one of the apartments. We were all very conservative, or rather had farm backgrounds or something else like that. But Barrington Hall was quite well known, and I knew at that time that a great many of the people in the building considered, well, if you've got any guts, you're a communist. If not, you're a socialist. So that provided. I didn't have, I mean, even though these people existed, say, in the hall when I was an undergraduate, I had really no part to do with them. I was a student. I worked hard. I didn't, I mean, I wanted to get good grades. I wanted to be a good chemist. And yes, they were there, but I had no knowing contact with them, even though some of them lived in the undergraduate. But then after I graduated from my undergraduate degree, I first lived in I-House, International House on campus, which is quite famous as a place where international students come and live. And after 1 year there, that was taken over by the Navy for a training site, and I just lived in an apartment in a house where a lady had several different rooms, and she rented them to students and made her living that way. And I lived with, I rented a room with another chemistry graduate student, and he worked in the chemistry department on a classified project, but it was not the atomic energy classified. There was in the department a lot of different projects that were secret, and I had financing either from the Navy or from some other source like that. I certainly heard talk about all of this, but I was too low down to be part of it, and I didn't want to. I was not socially motivated, and in that respect, I was a technologist. The one thing that might be sort of interesting to you was that before I went to work for the radiation laboratory, and I was taking coursework. You take your coursework during your first year and a half of your graduate period. We were urged very strongly to go over to the physics department and take a course in nuclear physics. Now, I didn't know why they wanted me to take a course in nuclear physics, but if they said, go and take it, it's important and interesting, why, I'll do that. And I went over and took this course, and it involved a review of nuclear physics, which I didn't know anything about at the time. And I remember that at one time he was discussing the fission of uranium and mentioning the fact, almost coyly, that you could make a chain reaction using this nuclear process. When I went to work for the laboratory, I had some better understanding of why they wanted me to take this course in nuclear physics at that time. I also found it was interesting that the professors who were suggesting what we took in the chemistry department had some feeling as what was going to be important in our future.
It's interesting that a lot of people think that the Manhattan Project was a physics project, but the reason, well, that the chemistry has not been much appreciated.
Yes.
You want to talk about that? Why that might be?
Well, no, there were many chemists all over, and anything anything that the physicists did is soon evolved into a chemical problem. And if you look at the history of who was winning the Nobel Prizes in nuclear, in new elements being discovered, they were mostly had a chemical background, because it was not only the physics of it, but then there was a lot of important chemistry in it. Well, you know, chemistry is, well, let me put it this way. I started out as a physical organic chemist and working on absorption spectra of dyes and using a spectrophotometer to make these measurements. After I had finished that, that was my PhD thesis. Then I became an inorganic chemist in the laboratory and worked as an inorganic chemist in the laboratory. After that, I started working with radioactive carbon-14 and making it into compounds which could be used. They were used, and very successfully, by biochemists, by medical people, and people of that sort. And I looked at them and says, you're getting all the credit in the paper for what I worked hard to make and provide for you. And so I turned into a biochemist. Now, and this is very characteristic of what you can do in a professional career. You can change your specialty a number of times as the need occurs and as your interests change. And so I classify myself now as a biochemist. I wandered into the field of nutrition because there were some very interesting problems on the metabolism of ascorbic acid, and I had radioactive ascorbic acid to study where it was, what it was used for, and so it is that science changes, and the one thing I can say to all young people who are thinking about it, start in on something, do well, but don't hesitate to change your field as the world changes around you. I'm very proud to have been part of the Manhattan Project, and I'm very thankful that we were successful. At the time that I was working on this, my brother is in the Philippines. He was an photo intelligence officer in the Air Force, and that meant he rode in a plane with big cameras and took pictures of what was to be targets or what targets had been successful. He had already been injured once by a bullet, which thank goodness didn't handicap him so badly that after a couple of months recovery in Australia, he was sent back to the Philippines and was waiting to be part of the invasion force that was going to invade Japan. He was saved. And I can only say how thankful I was that the war was brought to an abrupt end and peace was restored. My personal experience is, obviously, I'm very thankful.
What would you tell young people about the Manhattan Project? It's used all the time to say we need a Manhattan Project for global climate, or to solve climate change issues, or Parkinson's disease, or energy crisis. What would you say to people who talk about the Manhattan Project as something we could do again? Do you think that that's realistic? Can we do it? Have another Manhattan Project to solve energy issues or climate?
If you had a global enough, I mean, you do have a global problem. And if the solution was so readily apparent as it was to the scientists, Fermi and all the rest of them who participated in the Manhattan Project, then I think it could be done. It is not clear that the problems, with many of them have social overtones, have simple solutions. So I rather doubt. It would not be what you would expect. It would be something else.
How has people talk about the Manhattan Project, and Berkeley in particular, as changing the way science was done? If you look before the war and then after the war, and the sort of collaborative, interdisciplinary approach was something unique.
Yes, this is true. And this is proceeding at a very rapid rate today. Today, the cooperation between the various technologies has improved and yielded excellent results. Once upon a time, for instance, the chemists sort of were chemists. Now they have started in and are highly integrated both with medicine through their biochemistry departments and with technology with the engineers. For instance, I have a daughter who is a nanochemist, and she at UCLA. And nanochemistry, you say, oh, that's just chemistry. But it falls immediately into the area of engineering for new materials with new properties and new behaviors, and it falls into the area of medicine because these new particles have an entirely different behavior in the body and give new opportunities for making of therapeutic agents and delivering therapeutic agents. And it's this integration across many disciplines that has made science move forward much more rapidly than it used to.
How about Glenn Seaborg? Was he around and about?
Oh, yes.
Why don't you talk about him or your impressions of him and his team?
Well, he was a member of the department and one of the professors, and he was primarily into the inorganic portion of it and the radioactive. I didn't personally have any contact with him on a scientific level. I knew all of the professors in the department, and Glenn Seaborg was one of the really famous ones. But he was in a field that was much more inorganic chemistry than I, because I was in organic chemistry and then moved into the bio field of the chemistry. And so I didn't have any technical contact with him, but certainly all of the work that he was doing was outstanding. One of the things that I have noticed in looking at the history of the Manhattan Project is how few people have realized that the research laboratory for the Calutron at Oak Ridge was actually E.O. Lawrence's laboratory. And that E.O. Lawrence was apparently the first to spring into action, saying, look, I've got equipment and machinery and facility, and the Y12 was the first area that seceded. And of course, as in many things, you do the first time it one way, and then you realize that there are many other ways of achieving the same result, and then you abandon that. So it was one of the first of the various procedures in science that was abandoned in terms of the uranium and the fissionable uranium and plutonium as fissionable materials for nuclear power reactions. There is one thing I will say, that I have been very sad that nuclear power as a way of producing clean energy for our society has been not developed at any significant rate. I can only ascribe that to the fact that it's a pretty expensive form of energy, and that as long as there are wonderful supplies of methane and oil and everything else, that is probably going to sit on the sidelines. It's been a real pleasure to be able to talk about this. You got to remember that when you get to my age, there are virtually none of my colleagues left anymore. I think of the people that I worked with during the war years, and even of the years right after the war, are all gone. And so you wanting to make a record of this is an incredibly good deed.